Welcome to another video. So what we're talking about in this section is the cardiovascular and the respiratory system. And the reason that we've merged these two or even three systems, some would say, is because they're so interrelated. When one goes wrong, you're going to see pathology in the other. So at the bedside and bedside teaching that you do later on in the year, more so after Christmas, you will see that whenever a consultant or any kind of doctor analyses and reviews the cardiovascular system, there's going to be a respiratory correlate as well that they're going to be looking for. Now, to break it down very simply, cardio means heart, vascular means vessels, the blood vessels. The heart is the pump, as I'm sure you're all aware of, that pumps blood through the vessels to where it wants to go. So the vascular system is the highway of the body, and that's the most important thing to take just from this element. So if we look at the vascular system itself, you can think of a blood vessel as a tube, like a Pringles tube. But if we take a slice into that tube and then turn it 90 degrees, well, you'll see a circle. Now, what we have here is the tunica. So think of the tunic, your clothing. Tunica. And there are three different types, very logically named. The externa, the media, the middle, and then interna. So I want you to think of these as three concentric circles, like so. 1, 2, 3. Tunica intima, in this instance, is green. Tunica media will be blue. And then tunica externa is the red one. And then right in the center, so deep this internal layer, would have blood, which I'll colour in red again. So here is your blood. So the blood is touching the tunica intima. Now why is that important? Well, these tunics are made up of different things. The externa, the outer layer, is sort of like a protective shell that will hold it in place, sort of like a tortoise's shell, if you will. The media for muscle, MM. The middle layer is a muscular layer. So you think about it, it's not just your heart that's involved in propagating blood through the body, but these blood vessels themselves can contract to wriggle the blood through, sort of like the cardiovascular system with peristalsis, which we'll see later. And then the interna, the layer that's touching it, is very smooth. And it's smooth because you want free-flowing blood. So that's the tunica externa, media, and interna. Now why do we care so much about this? Well, you may have heard of atherosclerosis. Athero meaning artery or blood vessel, sclerosis meaning scarring. So multiple sclerosis is multiple scarrings throughout the nervous systems of the body. Now your atherosclerosis is scarring within this tunica intima. And what happens when the internal layer is scarred and damaged? Well, holes start to appear. And when you've eaten a lovely burger from McDonald's, what will happen is fat that's within your blood here, just flowing around, will get through these holes and will nestle in this space. Now this space is deep to the internal layer. So think about a submarine, deep to the water. We call this the sub-internal layer, or the sub-internal layer. So between the interna and the media is the sub-internal space. And in this sub-internal space is where the fat accumulates. When this fat accumulates with various other things, it will accumulate and accumulate and accumulate until it starts to make the hole through which blood can flow smaller and smaller and smaller. And by the time you get to a point where the blood flow is really small, let's have a look at the heart here. Look at all these fine blood vessels on the surface of the heart, like so. If we're blocking the flow, then these blood vessels that are the conduits, the highway for fuel and energy to get to your heart, they can't work sufficiently. That's the basis of a heart attack, which you'll cover in a lot more detail in Block 2. And later on, in bedside teaching, we'll see patients who've got angina and other kinds of heart disease. Atherosclerosis kills millions of people around the world every year. So understanding the structure of the blood vessels and where these problems are is vitally important. So let's just move on now from this. So we've looked inside a single layer of blood vessel. So what we'll do now is we'll take it a little bit further, we'll broaden it out, and we'll say that this is what your arteries and your veins have. Now what's the difference between an artery and a vein? You may have heard of this before. So what is the difference between an artery and a vein? Well, they both have the 3 tunicle layers. They both have the tunica externa, media, and interna. But the difference is the artery has more of everything. In particular, this middle muscular layer. So arteries are more muscular. So an artery will have more than the veins. Why is this important? Well, to understand this, we need to sort of understand where arteries and veins are in relation to each other in the body. If I start here with an artery, the artery, as it goes along, gets, from this big size here, it starts to get narrower and narrower until it becomes what's called an arteriole. You can think of that as a baby artery. This arteriole gets even smaller, much smaller, and forms what's called a capillary. At the other side, it's starting to grow, and we have a venule, or a mini vein, eventually growing into a massive thing called a vein. Now, for our purposes here, we can think of an artery as a distributive vessel. Okay? So the artery is connected to the heart, for instance. The heart pumps the blood, and the artery is the motorway that's distributing things throughout the body. So we have, for example, here we have our heart, here we have the aorta, and this big artery, the biggest artery in the body, receives blood from down here, this belly, ventrum, belly, pump up through the aorta to be distributed. So the artery is termed a distributive vessel. It has a lot of muscle here, so it can also contract to squeeze like a toothpaste tube the blood along. Arteriole is resistance. And why is it resistance? Well, because we've said it's getting smaller. Just like when you grab a hose pipe and you grab the end of the hose pipe and then the pressure increases at the end of the hose pipe, so you've got a bit of water just flopping out, and then you squeeze the hose pipe and it goes whoosh. That's what we're looking for here. So this is the resistance thing, just squeezing whoosh the circulation to keep it going. Capillary is the exchange layer. Because the capillary is where all our nutrients and all the goodies, the whole reason that we have blood, so our goodies come to the arteries, they come to the arterioles, and then they go through the capillary and out into the tissue around to supply things. That's where the fuel gets out. And then we dump our waste products through the capillaries into the venules and out to the veins. And these now are called capacitors. So these are the capacity vessels. Now why do we care about that? Well, capacity, think storage. The venules and veins are where the vast majority of the blood in your body at any one time is stored. The capacity. Okay. So that is a very quick overview of these arterial, arteriola, capillary, venule, and vein. And that's how it's arranged, a very generic overview. You will discover that all these different things have names, and that's anatomy, and that's what you'll be going to do. So, what we're now going to go to is the heart. And we're going to make this nice and simple, and then see what it actually looks like on the model. Okay? So you may have done the heart in GCSE, or A-level, or just sort of picked it up. It's a very commonly well understood organ. We're going to use the 4-box approach at this point. just to ensure that we've got the salient points down. This is the right side of the heart. This is the left side of the heart. So it's inverted for us looking at it, but the patient is stood here facing you. Their right side is your left side. So this is the right side of the heart. Okay? So the right side of the heart, up here, these two boxes are called atrium. So we have the right atrium. We have the left atrium. Now I want you to think of the atrium as an anteroom. It's a porch. It's the way into the heart itself. Ventricle. So this is the substance of the heart. This is the vast majority of the heart. Ventricle means belly, belly of the beast. It's this big puffy bit of the heart here. This is our ventricle. Okay? This is where most of the pumping action happens. This is where most of your blood resides. Right side, left side. Now, general rule of thumb. Let's say blood is green, worryingly. The atrium receive blood from outside of the heart, and the ventricles pump blood out of the heart. Okay? So the right atrium receives blood from a vessel that we won't go into right now, from the body. The left atrium receives blood from the lungs. Now what happens if we block this inflow into the left atrium? Well, the lungs will be full of blood. So you get blood on the lungs, you get fluid on the lungs, you start coughing up frothy sputum. It's pink. This is a side effect of heart failure. Heart failure will cause this left atrium to be less receptive to the blood from the lungs. So you'll damage your lungs. This is what I'm saying, where the heart and the lungs are so interconnected. Now remember, to keep the blood flowing nice and smoothly, we need to constantly be having a supply of blood into these chambers, so the ventricles, whose function we've already defined as being the big bellies of the heart that contract and push blood out of the heart to the body or back to the lungs. So body. So the left side, the left ventricle to the body. This one, right side to the lungs. Now let's follow this through so this makes a bit more sense. The body is bringing blood back to the heart. That means that this blood has already been used. It's full of dirt, it's full of waste, it's low in food. So it needs to get to the source of energy supply. One of the big ones is your lungs, where the air you're breathing in, lovely fresh oxygen is coming in. Oxygen will fan the fuels, fan the fire. You've already done this a bit in metabolism with John at the very start of the course. Oxygen is required for a lot of our respiration processes to generate that energy. So we need to turn this oxygen-poor blood from the body into oxygen-rich blood. So, body, right atrium. Right ventricle to the lungs. Yeah? Now the story carries on here, where we've now oxygenated, our lungs have expanded, we've oxygenated that blood, and it's now returning from the lungs to the left atrium, to the left ventricle, and then out to the body. Now let's complicate the story a little bit more. Here, and here, we have valves. Little doorways that prevent or allow blood to move depending on when we want it to, so that we can coordinate and ensure that all of our processes are flowing together nicely. So between the atrium and the ventricles, these valves are called the AV valves. The the atrioventricular valves. We've just merged the two words together to summarize their location. We call these the semilunar valves, SL valves. Semilunar, not because of where they are, like this one, but because they look like half-moon shapes. So the cusps that are the valves that hold the structure together, that are the doors, are semilunar shaped. Okay? Lunar like the moon. That is a quick overview of the heart. And that is a quick overview of how some heart failure can affect things and how backflow can occur. Okay? So if you had an issue with the right atrium, the walls were stiff, they'd gone big, there was a blockage, then blood will be not able to return from the body to be reoxygenated in the lungs, which means that you're going to have a patient who doesn't have enough oxygen, so they're fatigued, they're going a bit blue in the face for reasons that will become perfectly clear later on in the course. This blood remains in the body where it shouldn't be. Where will it remain? Well, it will remain, if you got the answer right, in those capacity vessels, those veins that we were talking. Because remember, the veins drain into the atrium here, this right atrium. So we're getting a backflow of blood that's not able to get into this right atrium, full of all of the toxic stuff that we don't want. It's backing up and it's damaging other organs. So depending on which side of the heart there is failure, you will see a cluster of different symptoms. If it's left-sided heart failure, the lungs are in trouble. If it's right-sided heart failure, it's the other way around. Right, welcome back. So, here we have, we're going to talk now, because remember that we said that the heart and the lungs are connected? Right, well, what I've drawn there is some lungs, in my wonderful style. I want to tell you, so you take a breath in. You can breathe in through your nose, you can breathe in through your mouth. Here's your nose, here's your mouth, there's your great big hideous looking tongue. When you breathe in through your nose, it goes through a series of different channels to warm, to moisten. It goes up here so that smell can get to the brain. A whole load of things happen that you'll study in detail in block 2 and a bit more in block 3 as well. So the mouth will go through here, and it will travel along here. This region at the back of the throat is called the pharynx. It's divided up into 3 parts that you'll study in detail in block 2 again. This pharynx communicates with the larynx. The back here is your gullet, your esophagus. So food enters your mouth. This bit rises up here to close off the nose so you don't, your pizza that you're eating doesn't go into your nose. And then it drops down into your gullet. But we're not concerned about that right now, because what we want to know is how air gets to our lungs. So, we breathe in, comes this common outflow here, the pharynx, and then down here it goes into the larynx. Interestingly enough, here are your vocal folds. Again, you'll cover this in block 2, close to Christmas. These vibrate with air to phonate, to enable you to make sounds. Okay? Air will come in here, into the larynx, and then down into your trachea, your windpipe here. And the story picks up on the board. So, here's our trachea in green, the windpipe, and the trachea will split at a characteristic part. So we've done the vertebra at this point, T4. T4 is represented on the front here by this sternal angle. Let me bring this a bit closer. So T4 is this sternal angle here, which is this portion of the sternum. If we go right back in that same plane, this is where our trachea, our windpipe, splits in two. So it's a very good surface anatomy point. And what we'll end up with is our trachea splitting into these things called the bronchi. So let's label these now, shall we? So we have a trachea, we have bronchi, and these bronchi divide further when they reach these bags, these lungs here. This is the right lung, this is the left lung. Remember, inverted. The right lung is here, the left lung is here. So our trachea is coming down here. It's split at this level into two. One to the right lung, one to the left lung. This right lung has 3 lobes. An upper lobe, a middle lobe, and a lower lobe. Notice that the left only has 2. It only has an upper lobe and a lower lobe. There are fissures, big cavities that split this lung substance into 3 different lobes. This fissure is imaginatively called the horizontal fissure. This fissure is called the oblique fissure. So it's safe to say that the oblique fissure divides the middle right lobe from the inferior right lobe. Okay, that's a quick overview of the lungs. Very quick overview of how they're arranged. Okay, right, so here's a slab of thorax. So what we have here, we have the right lung, we've got the left lung. Note that there's a little space in the left lung here called the lingula, which is because the heart sort of pokes into it. It's displaced in embryology. Now what we have here is the right lung, which is made up of the 3 lobes. So we can have here, so get a bit closer. So we've got this fissure here, and then we have another fissure here. So there's your horizontal fissure, there's your oblique fissure. Now let's take this off. So it's quite precarious, and you can see the heart in situ here. Now if I take the heart out, let's pop this on the floor. So what we have here is the open heart. Now, here's your atrium, here's your ventricle. So between the two is the atrioventricular valve. Okay, as you can see here. This is called the tricuspid valve because it has 3 cusps. 1, 2, and then a third one quite deep in there that's kind of hard to see. Tricusp, 3 cusps. This one's called the bicusp, or 2 cusps. It's also called the mitral valve. We'll be listening to both of those in a minute over there. And then we have another one here called the pulmonary valve. This is a semilunar valve because it has the crescent-shaped moon-like structures. And there's a 4th one which is here with this red tube, the aorta here, called the aortic valve, which we can't see. But these 2 are semilunar and these 2 are atrioventricular. So between the atrium and the ventricle, between the ventricle and the outflow.
Hello, my name's Nick, this is Dave, and this is Dan. Today we're going to be showing you how to do a cardiac and also respiratory exam, listening to the chest. This is something you'll learn in clinical placements in year 1, and also you'll be practicing in hospital placements as well. Okay, Dan, would you like to proceed?
Yeah. Hello there, my name's Dan, I'm one of the first year medical students. Can I get your full name and date of birth, please?
Yeah, it's David Tuffley, and it's the 7th of February 1996.
Lovely. And what would you like to call you today?
Dave is fine.
Dave, Dan. I've got my consultant here, Dave, and he wants me to have a listen to the valves specifically of your heart, and then the front and back of your lungs with my stethoscope here. Is that okay?
Yeah, that'd be fine.
Fantastic. Okay, you pop your shirt up, just line that couch for me. I'm going to have a listen to you on the other side. So that's okay?
Yeah, that's fine.
Always listen to the right side. Okay, just try and relax.
So Dan's going to be listening to each heart valve in turn. So it starts off with the aortic, then the pulmonary, and then the tricuspid, and followed by the mitral. So he's listening to specific sounds. So stenosis will show narrowing of the valve, and then regurgitation will show that the blood is flowing back, so it may show that the valve isn't functioning properly. Okay, Dan, can you now progress into the lungs?
Yes. I'm going to have a listen to your lungs, okay? That's right with you. So I'm just going to get you to take some deep breaths in and out every time I pop my stethoscope on your chest. Okay?
Yeah, fine.
Okay, breath in. And out.
So Dan's now listening to each lobe in turn. As we've gone over earlier, there's different numbers of lobes on each side. So there's 3 on the right and 2 on the left. So starting off with the upper lobe, and then the lower lobe as well, and then the upper, middle and lower lobe. Different things, or different noises will indicate different things. So crackles, pneumonia. If you can't hear something or it's resonant, it may indicate a pneumothorax. Also listening to a wheeze as well may indicate infection. It's also important to listen to both the front and the back, and also listening to the back helps you listen to the lower lobes. Listening to the side, the middle lobe, so listening to the axilla, and the front, the upper lobe as well.
Safe one. So I'm just going to pop the stethoscope back on you now.
Okay.
I'm just going to say the word just 99. Okay?
Fine.
Every time I do.
So Dan's
99.
listening for resonance, which may indicate
99.
a pneumothorax. Okay? It's very simple. All you get is the patient to say, repeat 99 after you and listen to the same regions you listened to before.
99.
Lovely. Thank you, Dave. You can sit back on the top. Pick up your top of the thing. And that's the end of our exam. Thank you very much.